Welcome to Curiosity, the podcast where science meets wonder. Join us as we explore the fascinating, the innovative, and the unexpected. From the secrets of the cosmos to the marvels of everyday life, each episode takes you on a journey to uncover the knowledge and stories that fuel our endless quest for understanding. Let your curiosity guide you.
Reptiles, survivors, adaptations, and the timeless legacy of Earth's ancient creatures. Reptiles, a group of animals that includes some of the most ancient and diverse lineages on Earth, have played a crucial role in the evolution of life as we know it. Their history spans over 300 million years, from the early Paleozoic era to the present day, and they represent a remarkable testament to the power of evolutionary adaptation. From the first tetrapods that crawled out of the seas to the mighty dinosaurs that ruled the land, reptiles have adapted to nearly every ecological niche on the planet. This first part will delve into their origins, early evolutionary history, and the major milestones that have shaped this fascinating group. The origins of reptiles trace back to the late Carboniferous period, about 320 million years ago. During this time, the Earth's landmasses were dominated by vast swamps and dense forests, which were home to an abundant array of amphibians. However, these amphibians, while successful, faced significant limitations, particularly with regards to reproduction. Their dependence on water for reproduction meant that they could only live in or near aquatic environments, leaving them vulnerable to environmental changes that could dry up their habitats. It was within this context that the first reptiles emerged. Reptiles evolved from amphibian ancestors that had already begun to adapt to life on land. The key innovation that set reptiles apart was the development of the amniotic egg, a self-contained unit capable of supporting the developing embryo without the need for water. This egg, with its hard or leathery shell, allowed reptiles to lay their eggs on dry land, thus opening up vast new habitats for them to colonize. The evolution of the amniotic egg was a monumental step, as it freed reptiles from their reliance on aquatic environments for reproduction and allowed them to expand into drier, more diverse ecosystems. The earliest reptiles were small, lizard-like creatures that coexisted with amphibians. These early reptiles belonged to a group called the Reptiliomorpha, which includes both extinct lineages and the ancestors of modern reptiles. They were characterized by their scaly skin, which prevented water loss and further enhanced their ability to live in arid environments. Over time, these early reptiles gave rise to several major groups, each of which would evolve into the diverse array of reptiles we recognize today. Among the earliest major groups of reptiles were the synapsids and diapsids. Synapsids, which would eventually give rise to mammals, were the dominant terrestrial vertebrates for much of the early Mesozoic era. Diapsids, on the other hand, led to the modern reptiles, including lizards, snakes, crocodiles, and birds. The diapsid lineage is particularly significant because it includes the ancestors of the dinosaurs, the creatures that would go on to become some of the most iconic and successful animals to ever walk the earth. The rise of the dinosaurs during the Triassic period, around 230 million years ago, marked one of the most significant events in the history of reptiles. Dinosaurs, with their unique body plans, large size, and varied adaptations, dominated the terrestrial ecosystems for nearly 165 million years. The first dinosaurs were small and bipedal, but they quickly evolved into a vast array of forms, ranging from massive, long-necked sauropods to swift, agile theropods. Dinosaurs were able to dominate the planet for so long due to a combination of factors, including their efficient metabolism, diverse feeding strategies, and the fact that they occupied a wide variety of ecological niches. One of the key evolutionary innovations that helped the dinosaurs become so successful was the development of the upright, bipedal posture. This allowed them to run faster, breathe more efficiently, and grow larger than many of their competitors. This upright posture, along with other adaptations like the development of specialized teeth and jaws, gave dinosaurs a significant advantage over other reptiles and vertebrates. As the Mesozoic era unfolded, the dominance of dinosaurs became evident as they diversified into nearly every possible ecological role, from apex predators to massive herbivores. While dinosaurs were the dominant terrestrial reptiles, other groups of reptiles continued to thrive during this time. Pterosaurs, for example, were flying reptiles that evolved from diapsid ancestors and were the first vertebrates to achieve powered flight. These creatures, with their long wingspans and adaptations for flight, occupied the skies of the Mesozoic, feeding on fish, insects, and other small animals. Pterosaurs were an essential part of the Mesozoic ecosystem, and although they were not dinosaurs themselves, their evolutionary success demonstrated the versatility of the reptilian lineage. Meanwhile, in the seas, the marine reptiles such as ichthyosaurs, plesiosaurs, and mosasaurs ruled the oceans. These reptiles evolved from land-dwelling ancestors that returned to the sea, adapting to the aquatic environment in remarkable ways. Ichthyosaurs, for instance, had streamlined bodies and tail flukes that allowed them to swim at great speeds, much like modern dolphins. Plesiosaurs, with their long necks and paddle-like limbs, were equally well adapted to marine life, capturing fish and other prey in the oceans. Mosasaurs, a group of giant reptiles that appeared later in the Cretaceous period, were apex predators in the oceans, preying on fish, marine reptiles, and even smaller sharks. The evolution of reptiles also saw the emergence of crocodiles, which, like dinosaurs, have remained largely unchanged for millions of years. Crocodiles first appeared in the late Triassic period, and over time, they evolved into the formidable predators we recognize today. Their armored bodies, powerful jaws, and exceptional swimming abilities have allowed crocodiles to survive through dramatic changes in the Earth's climate and ecosystems. Crocodiles are considered living fossils because their basic body structure has remained remarkably consistent for over 200 million years. By the end of the Mesozoic era, however, the reign of the dinosaurs came to a sudden and dramatic end. The cause of their extinction, most likely a combination of volcanic activity, climate change, and the impact of an asteroid, wiped out the dinosaurs and many other reptile species. However, reptiles did not disappear with the dinosaurs. Instead, they entered a new phase of evolution, with the survivors adapting to the post-dinosaur world. The extinction of the dinosaurs paved the way for the rise of mammals and the eventual dominance of birds, which are the modern descendants of the dinosaurs. Nevertheless, reptiles, in various forms, continued to thrive. After the catastrophic extinction event at the end of the Cretaceous period, which wiped out the non-avian dinosaurs, the surviving reptilian lineages entered a new chapter in their evolutionary history. Although the dinosaurs were gone, many other groups of reptiles managed to adapt and evolve, filling ecological niches left vacant by the extinction of these giant creatures. This period, which marked the dawn of the Cenozoic era, was pivotal for reptiles, as they diversified and continued to thrive, each group developing unique adaptations that would allow them to persist in a rapidly changing world. The immediate aftermath of the dinosaur extinction saw the rise of mammals as the dominant terrestrial vertebrates, but reptiles, which had coexisted with mammals for much of the Mesozoic, continued to play a significant role in Earth's ecosystems. Among the survivors were groups like the crocodiles, turtles, lizards, and snakes, each of which adapted to new environmental pressures and began to diversify in fascinating ways. Crocodiles, which had existed alongside dinosaurs for millions of years, were among the most successful reptile survivors. These resilient animals were well equipped to cope with the changing world. Their semi-aquatic lifestyle, armored bodies, and powerful jaws allowed them to dominate freshwater and coastal ecosystems. Crocodiles continued to thrive in rivers, lakes, and marshes, occupying niches as apex predators. Over millions of years, they have maintained a relatively stable evolutionary path, with little change in their overall form. They survived through dramatic climate fluctuations, from the warming of the Earth to the cooling and drying periods that followed, remaining one of the most successful and unchanged reptilian groups. One of the most striking features of crocodiles is their remarkable adaptability. They are capable of living in a wide range of habitats, from freshwater rivers and lakes to brackish coastal waters. Crocodiles also have an exceptional ability to regulate their body temperature by basking in the sun and retreating into the water to cool off, a characteristic that allows them to survive in both tropical and subtropical climates. In addition, their reproductive strategy, which involves laying eggs in protected environments, has enabled crocodiles to thrive in environments where many other species might struggle to reproduce. Similarly, turtles, another ancient group of reptiles, persisted through the mass extinction event. Turtles, with their protective shells and unique adaptations for life both in water and on land, continued to diversify. Over time, some species evolved to live in aquatic environments, while others adapted to terrestrial life. The unique evolution of their shells, which serve as both armor and a means of regulating body temperature, has been a key factor in their survival. The diversity of turtles today, from the small box turtles to the massive leatherback sea turtles, reflects their ability to adapt to a wide variety of environments, from deserts to oceans. The earliest turtles, known as the stem turtles, first appeared during the late Triassic period, but it was in the Cenozoic era that their evolutionary trajectory began to take shape. They split into two main groups, the Pluridaira, side-neck turtles, and the Cryptodaira, hidden-neck turtles. The former group is found primarily in the southern hemisphere, while the latter is more widely distributed, with species found in North and South America, Europe, and Asia. The development of the turtle's shell is considered one of the most significant evolutionary adaptations in reptile history. The shell, made of bony plates, offers both physical protection from predators and the ability to store water, a vital adaptation for survival in arid environments. Lizards and snakes, collectively known as squamates, underwent significant diversification after the extinction event. Lizards, with their wide variety of body forms, behaviors, and ecological roles, are among the most adaptable and successful reptiles. From the tiny, fast-moving geckos to the formidable monitor lizards, squamates evolved a range of adaptations that allowed them to thrive in diverse habitats, from deserts and forests to grasslands and caves. Snakes, a subgroup of squamates, also experienced a remarkable evolutionary journey. These legless reptiles are believed to have evolved from lizard-like ancestors, losing their limbs over millions of years. The loss of legs, along with the elongation of their bodies, allowed snakes to move through narrow spaces, burrow, and pursue prey with exceptional agility. Their highly specialized digestive systems, which enable them to consume large prey in a single meal, further contributed to their success as predators. Additionally, snakes have developed a range of venomous and non-venomous species, each with unique adaptations for hunting and defense. Some snakes, like the boa constrictor, use constriction to subdue prey, while others, like vipers and cobras, rely on venom to immobilize and kill their prey. Snakes also exhibit a wide variety of reproductive strategies, with some species laying eggs and others giving birth to live young. Their ability to reproduce in diverse environments, combined with their highly developed sensory systems, including heat-sensing pits in some species and exceptional olfactory capabilities in others, has allowed snakes to become successful predators across the globe. Throughout the Cenozoic era, reptiles continued to adapt to environmental shifts, including dramatic climatic changes and the rise of new competitors. While mammals began to dominate many ecosystems, reptiles maintained a presence in both terrestrial and aquatic environments. This was particularly evident in the oceans, where sea reptiles like sea snakes and marine turtles flourished. Sea snakes, a group of highly specialized reptiles, evolved to live in the ocean, where they developed adaptations like flattened tails for swimming and the ability to breathe air while hunting underwater. Marine turtles, with their long migrations and remarkable ability to navigate across vast oceanic expanses, continue to play a key role in marine ecosystems today. Despite the rise of mammals and birds, reptiles remained an integral part of Earth's ecosystems. Their ability to regulate their body temperature, their diverse reproductive strategies, and their capacity to adapt to a wide range of environments allowed them to persist through changing climates and the advent of new competitors. Some reptiles, like the Komodo dragon, continue to be apex predators in their environments, while others, like the Gila monster and various species of geckos, have adapted to more specialized niches. In the modern world, reptiles continue to thrive in a variety of ecosystems, from the deserts of Africa to the rainforests of South America, from the warm coastal waters of the Caribbean to the frozen shores of the Arctic. They remain one of the most diverse and ancient groups of animals, with over 10,000 species spread across the globe. Some, like the tuatara of New Zealand, are considered living fossils because they have changed very little over millions of years, offering a glimpse into the distant past of reptilian evolution. The evolution of reptiles has been marked by a continual process of adaptation, as these creatures have navigated an ever-changing world. From the earliest amniotes that first ventured onto land to the highly specialized reptiles that now inhabit nearly every environment on Earth, the story of reptiles is one of resilience, diversity, and innovation. In this final part, we will explore the continued diversification of reptiles, their current ecological roles, and the challenges they face in the modern world, including the pressing need for conservation. Throughout their history, reptiles have evolved into an incredibly diverse array of species. Today, reptiles are categorized into several major groups: squamates, lizards, snakes, and amphisbaenians, turtles, crocodilians, and tuataras. Each of these groups has developed unique characteristics that enable them to thrive in a variety of ecosystems, from the scorching deserts to the lush rainforests, from the vast oceans to the cold Arctic regions. Squamates, the largest and most diverse group of reptiles, include over 10,000 species, making them the most numerous. This group is divided into lizards, snakes, and amphisbaenians, each with its own remarkable adaptations. Lizards, for example, come in an astonishing range of forms and behaviors. Some, like chameleons, have evolved the ability to change color, using their skin pigmentation to communicate, camouflage, or regulate their body temperature. Geckos, another subgroup of lizards, possess specialized toe pads that allow them to climb smooth surfaces and even walk upside down, a skill that has made them incredibly successful in urban environments. Snakes, another branch of squamates, have become one of the most successful and specialized groups of reptiles. Their elongated bodies and lack of limbs allow them to move with incredible speed and flexibility, making them highly effective hunters. Snakes have also developed diverse methods of subduing and consuming prey. Some, like pythons and boas, constrict their prey, while others, like cobras and vipers, use venom to immobilize or kill. The development of venom has been a critical evolutionary advantage for many snake species, allowing them to capture larger prey and defend themselves from predators. Additionally, the ability of snakes to detect prey through infrared sensing, in some species, or chemical signals through their tongue, further enhances their hunting capabilities. Amphisbaenians, often overlooked in popular discussions about reptiles, are a group of burrowing reptiles that have evolved highly specialized features for life underground. These creatures, also known as worm lizards, have cylindrical bodies and are equipped with powerful jaws and sharp teeth for burrowing through soil. Their eyes are often reduced, and their bodies are adapted to an underground lifestyle where they hunt for insects, small invertebrates, and other subterranean prey. Although amphisbaenians are not as well known as lizards and snakes, they represent an intriguing example of how reptiles can evolve to occupy unique ecological niches. Turtles, as discussed earlier, are among the oldest surviving reptilian groups. With over 300 species today, turtles are characterized by their unique bony or leathery shells, which provide them with protection from predators. The evolution of the turtle's shell is one of the most remarkable events in reptilian history, as it provides an unparalleled defense mechanism. Turtles are found in a variety of habitats, from the oceans to freshwater rivers and lakes, and even in some of the most arid deserts. Sea turtles, for instance, are long-distance travelers, migrating thousands of miles between feeding and nesting sites. Their migration patterns are guided by magnetic fields, a remarkable adaptation that has allowed them to navigate the vast oceans for millions of years. Crocodilians, which include crocodiles, alligators, caimans, and gharials, are another ancient group of reptiles that have changed little over the millennia. These apex predators have a number of specialized features that make them formidable hunters. Their powerful jaws, armored bodies, and excellent swimming abilities allow them to dominate freshwater and coastal habitats. Crocodilians have also developed a remarkable ability to regulate their body temperature by basking in the sun and retreating into water to cool off, a trait that helps them survive in both tropical and temperate climates. Their reproductive strategy, which involves laying eggs in nests, ensures that their young are protected in the early stages of development. Some species, like the saltwater crocodile, are capable of traveling long distances across the sea, further extending their range and ecological influence. The tuatara, a unique reptile found only in New Zealand, represents a living fossil in many ways. The tuatara is the sole surviving member of the order Rhynchocephalia, a group of reptiles that flourished over 200 million years ago. While it bears a resemblance to lizards, the tuatara is distinct in its morphology, including a well-developed third eye located on the top of its head. This parietal eye is believed to help the tuatara regulate its circadian rhythm and sense light levels, which is a rare trait among reptiles. The tuatara's slow metabolism and long lifespan make it an intriguing example of evolutionary stasis, as it has remained largely unchanged for millions of years. Today, reptiles play vital ecological roles across the planet. As predators, they help regulate the populations of smaller animals, preventing the overpopulation of certain species and contributing to the overall balance of ecosystems. For example, snakes help control populations of rodents, which can become pests in agricultural areas. Similarly, crocodiles and alligators keep the populations of fish, amphibians, and even larger animals in check in their aquatic environments. Lizards, such as geckos, are essential insectivores that help manage insect populations in both urban and rural areas. Turtles, particularly sea turtles, contribute to the health of marine ecosystems by grazing on seagrasses and helping maintain the health of coral reefs. Reptiles also have cultural and economic significance for humans. Many species, such as crocodiles and turtles, are valued for their skins, which are used in the fashion industry. The pet trade has also contributed to the popularity of reptiles, with species like snakes, lizards, and turtles being kept as pets around the world. Reptiles also have medicinal value in some cultures, with certain snake venoms being studied for their potential to treat medical conditions such as blood pressure problems and clotting disorders. Despite their resilience and adaptability, reptiles face numerous threats in the modern world. Habitat destruction, climate change, pollution, and the illegal pet trade have all contributed to the decline of many reptile species. Habitat loss due to deforestation, urbanization, and agricultural expansion has led to the fragmentation of ecosystems and the reduction of suitable habitats for many species. Climate change poses a particular challenge for reptiles, as their ectothermic nature, reliance on external temperatures to regulate body heat, makes them vulnerable to temperature fluctuations. For example, sea turtles are highly sensitive to temperature changes, which can affect their nesting sites and the sex of their offspring. Conservation efforts are crucial to ensuring the survival of reptiles in the face of these threats. Various organizations and governments are working to protect endangered reptile species through habitat restoration, captive breeding programs, and legal protections. Many countries have implemented laws to regulate the trade in endangered reptiles and prevent the destruction of critical habitats. In addition, efforts to combat climate change and reduce habitat fragmentation are essential for the long-term survival of reptilian species. The continued evolution of reptiles, despite the challenges they face, underscores their remarkable ability to adapt and survive over millions of years. From the first land-dwelling amniotes to the diverse range of reptiles we see today, they have demonstrated a remarkable capacity for survival and innovation. As we continue to explore and study these fascinating creatures, it is clear that reptiles will remain an essential part of the natural world, playing key roles in maintaining ecological balance and offering invaluable insights into the processes of evolution and adaptation. Their preservation is not only critical to the health of ecosystems but also a testament to the enduring legacy of life on Earth.